To understand the diversity of artificial intelligence, we must look at the different ways we can structure a neural network. Break time equals 0. 2 slash at the most fundamental level, we have feedforward networks. Break time equals 0. 2 slash in this architecture, information moves in one single direction, from the input nodes, through any hidden layers, and straight to the output. Break time equals 1. 5's, the simplest version of this is the single layer perceptron. Break time equals 0. 2's, it consists of only one layer of neurons that takes multiple inputs, applies a specific weight to each, and sums them together. Break time equals 1, 0. This sum is then passed through an activation function to produce a result. Break time equals 1, 0. While the single layer perceptron is the building block of modern AI, it is limited to solving linear problems where data can be easily separated by a straight line. Break time equals 1, 5's. To handle the complexity of the real world, we need to expand this structure into multiple dimensions. When we stack multiple layers of neurons together, we create a multi-layer perceptron, often referred to as an MLP. Break time equals 1, 5 slash an MLP consists of at least 3 layers, an input layer, one or more hidden layers, and an output layer. Break time equals 1, 0 slash unlike its single layer predecessor, the MLP utilizes nonlinear activation functions. Break time equals 1, 0's. This is a critical distinction because it allows the network to learn and model complex, nonlinear relationships between inputs and outputs. Break time equals 1, 5's. By passing data through these hidden layers, the network can identify abstract patterns that are not immediately obvious. Break time equals 1, 0. This multi-layered approach forms the foundation of what we now call deep learning, enabling machines to process sophisticated datasets with much higher accuracy. While MLPs are powerful, they are not always the most efficient choice for processing visual information. Break time equals 0. 2 slash for tasks like image recognition, we turn to the convolutional neural network, or CNN. Break time equals 1, 5 slash a CNN is specifically designed to understand the spatial hierarchy of data. Break time equals 0. 2's, instead of treating an image as a flat list of numbers, it uses convolutional layers to scan the image for local patterns. Break time equals 1, 0's. These layers act as filters that automatically learn to identify features like edges, corners, and textures. Break time equals 1, 5's. As the data moves deeper into the network, these simple features are combined to recognize complex objects, such as a human face or a stop sign. Break time equals 1, 0 slash by focusing on local connections rather than global ones, CNNs significantly reduce the number of parameters the network needs to learn, making them incredibly effective for computer vision. Not all data is static. Sometimes, the order of the information is just as important as the data itself. Break time equals 0. 2's. This is where recurrent neural networks, or RNNs, come into play. Break time equals 1, 5 slash unlike feedforward networks, RNNs use feedback loops that allow information to persist within the system. Break time equals 1, 0's. This creates a form of internal memory, making them ideal for sequential data like spoken language or time series predictions. Break time equals 1, 5's. However, standard RNNs often struggle with long sequences because they tend to forget information from the very beginning, a problem known as the vanishing gradient. Break time equals 1, 0 slash to solve this. We use a specialized type of RNN called long short-term memory, or LSTM. Break time equals 1, Zeros/LSTMS use a complex system of gates to selectively decide which information to store, which to discard, and which to pass forward. Break time equals 1. Zeros. This allows the network to maintain context over much longer periods, which is essential for tasks like translating a long paragraph or predicting future trends in a fluctuating market.